In this video, we're going to start looking at transformations of tangent and cotangent. And so I've got a function up here on the board. Looks like it's a transformation of tangent. And here are our lovely directions. We're going to graph exactly 2 periods, starting and ending at an asymptote. And I'm asking that we label the 3 important points in just 1 period. Okay. I figure if you can do that in 1 period, you can probably do it in the 2nd period too. Okay. So, looking at this, I can see I'm going to write this input in factored form. So -2 tangent times pi times x minus a half. Not absolutely necessary to do that, but I like that because now I can see my net result should be that I've shifted things 1/2 unit to the right. Okay, so that gives me a nice way of double checking things. It's a little harder to see that from here. Okay, the stuff that I'm plugging in, all of that is going to affect the graph horizontally. And then anything I do after I evaluate tangent, which in this case is multiplying by -2, that's going to affect the graph vertically. Okay, now for the vertical transformations, I can do exactly what I do with sine and cosine. The y values that I care about in my basic parent function are 1, 0, and -1. The difference is with tangent and cotangent, 1 and -1 are not high and low values. They're just sort of the values that I hit 1/4 and 3/4 of the way through a period. They help me to get the right steepness for the graphs. So they're important points, they're just not highs and lows. Okay. Looks like I'm multiplying by -2. So that's going to stretch things by a factor of 2 and flip things. So 1 becomes -2, 0 stays at 0, -1 becomes +2. And there's nothing from just writing those numbers that indicates that we flipped. So I like to write, we have flipped. And what does that mean? Well, I'm not starting at any one of these numbers. I hit all of these on my way through. But with a regular tangent graph, I would always be going up. So if I flipped it, I'm always going to go down. I'll just write that in so I don't forget. Okay, let's take a look at the horizontal stuff. Now I have to be careful here because the period of tangent and cotangent is pi, not 2 pi. I'm really used to saying my trig function does its thing once as we vary from 0 to 2 pi. Don't want to say that here. I know that the period is pi, so I want to look over an interval of length pi. I also know that I want to start and end at an asymptote. And I know that tangent has asymptotes at odd multiples of pi over 2. So I'm going to say -pi/2 to pi/2 is the standard period that I usually draw. And notice I've used strict inequalities here because x can't be those values because tangent's undefined there. So I'm going to say my input, pi times x minus 1/2, would have to be strictly between -pi/2 and pi/2. When I solve for x, whatever these numbers become are going to become the location of my starting asymptote and my ending asymptote for that first period. Okay, so let's divide by pi. I'm just going to use the fact that dividing by pi is the same as multiplying by its reciprocal. So those pi's cancel. I get -1/2 less than x minus 1/2 less than +1/2. Let's add that half. So 0 is less than x is less than 1. Okay, so I can see now my new period should be 1 because that's 1 minus 0. That's the difference between my ending point and my starting point. That's also the original period pi divided by this number that I'm multiplying by. So I can calculate it one of 2 ways, and I get the same thing either way. Period is 1. Okay, excellent. So that's going to mean that the increment, let's see, we'll erase the directions. The increment is going to be 1/4. And so the x values that I want to plot, I'm going to start at 0 and I'm going to count over by 1/4. So 0, 1/4, 2/4, which will reduce to 1/2, 3/4, and then 4/4, which simplifies to 1, which is supposed to be my ending point for that first period. Okay, fabulous. So let's graph this. So we're starting at 0. That's the location of an asymptote. I'm going to mark off 1/4, 1/2, 3/4, and 1. This is just for my first period. So I'd have an ending asymptote there. Okay. And then the y values that we care about are 2, 0, and -2. And because we flipped it, we're going to be going down. Okay. So 1/4 of the way through we'll be at 2, halfway through we'll be at 0, 3/4 of the way through we'll be at -2. And so my graph is going to look something like so, going down. Okay. And then we were asked to draw 2 periods. So we had 0, 1. My next asymptote will be at 2. And I could certainly, if I wanted to, easily fill in the points. I've only asked you to label the points in 1 period, so you can just sort of draw this one freehand if you like. If you prefer to label the points in the 2nd period, that's totally fine. Okay, excellent. Should be a little bit smoother than that. My hand was shaking. It doesn't really bobble back and forth. It's just a nice smooth curve. Okay, excellent. So that's our transformation for tangent. Now I said we should be able to look at it and see that we had moved things 1/2 to the right. Now I can, but I have to be very, very careful. This asymptote is not 1/2 to the right of where it was, because it was at -pi/2. Okay? But any value other than 0 is affected by both the multiplication and the addition and the subtraction. It's only the 0 that's only affected by the addition and the subtraction. Now 0 on a regular graph of tangent is halfway in between my 2 asymptotes. A regular graph of tangent looks like so. So the midpoint of my first period is at 0. Here's the midpoint of my first period, that's at 1/2. So we did shift things 1/2 to the right. But do be careful when you're checking. Anything that started at a non-zero value is going to be affected by both transformations. It's only the 0 that's only affected by the addition or the subtraction, so only affected by the shifting. All right, that was a good one. I want to do one with cotangent. I want to give you folks a chance to try. So I picked one from the homework. So this is number 55 from the homework. So sketch for me y equals cotangent of 2x plus pi/3. Okay. And same directions that I just erased up here. Graph me exactly 2 periods. Make sure you start and end with an asymptote. And label the 3 important points for at least one of the periods. Okay? And then we'll go over that together at the beginning of the next video.